Hello, and welcome to Game Theory. I'm Professor Naomi Utgoff of the United States Naval Academy. In this first video about dynamic games of complete information, we'll define the extensive form of a game and introduce its game tree representation. We'll begin by exploring dynamic games of complete information and contrasting them with other types of games. Let's revisit the classification of non-cooperative games. Recall that since a game is a setting in which players strategically interact, we need players and rules, and the delineations of static versus dynamic and complete versus incomplete information games tell us what kind of players and rules we can expect. Dynamic games are games of sequential moves, and games of complete information are those in which the game itself is common knowledge. Tic-tac-toe is a dynamic game of complete information. As with static games of complete information, we begin our study of dynamic games of complete information by considering how to represent such games. We've discussed dynamic games of complete information enough to give an example of such a game, tic-tac-toe. Now we'll define the extensive form of a game and its tree representation. We'll begin with the extensive form. Loosely speaking, the extensive form is the analog of the normal form. It is a list of all the components of the game. However, a dynamic game of complete information has some components that a static game of complete information lacks. The first and last components, the list of players and their respective payoff functions, are familiar. Items 2, 3, and 4 require some introduction. Item 2, the order of moves, means that we know whose turn it is to act at a point in time during the game. The order of moves may be fixed, as in tic-tac-toe, or depend on how the play of the game unfolds, as in Wheel of Fortune, in which it's possible to lose a turn. Item 3 tells us we should specify actions, whereas the normal form specified strategies. Roughly, the distinction between actions and strategies is that an action is a choice available at a specific move, while a strategy is an overarching plan for all moves. For now, we will work with this informal understanding. However, this distinction is so important that we will devote all of the next video to understanding the relationship between actions and strategies. Item 4, information about the history of play, means we need to specify at each move what a player observes or remembers about actual play of the game up until that point. Importantly, there is a distinction between information about the play of a game and information about the structure of a game. Complete versus incomplete information refers to information about the structure of the game itself. We are dealing in games of complete information because players know the full extensive form. We will mostly limit ourselves to dynamic games of complete and perfect information. Tic-tac-toe is a dynamic game of complete and perfect information since a player knows the full history of the game because she can see on the grid which squares have been claimed by which player. Here is the extensive form of tic-tac-toe. It names the players, X and O, and tells us how to play. Following these directions would enable you to play tic-tac-toe even if you had never played it before. When you look at the rules for Monopoly, Scrabble, chess, and so on, they are telling you the extensive form of the game. Even if you have never played one of these games, by reading the rules, you can learn how. Let's take a moment to consider the extensive form of Cournot Duopoly, a static game of complete information. Here is the normal form of Cournot Duopoly from video 9. In the case of static games of complete information, the normal and extensive forms coincide. The players and payoff functions are unchanged. The order of moves is the specification that players move simultaneously and independently. Each player has exactly one move, so actions and strategies coincide. The information about the history of play is non-existent. There is no history to observe, since each player selects her action without knowing the selection of the other player. In other words, Cournot Duopoly is a game of imperfect information. Finally, let's turn our attention to the game we'll use in this video to introduce the game tree, and in the next video as we dissect the distinction between actions and strategies, dynamic battle of the sexes. We'll take a bold lurch forward to at least 1983 and give both of our players cell phones. The man leaves work first and selects either boxing or ballet. Then he calls the woman and tells her where he went. When she leaves work, she decides whether to follow him or not. The woman has two moves, one following the man's selection of boxing and the other following his selection of ballet. Only one of these moves occurs during play, but she nevertheless has two moves to plan for. The woman therefore has two action spaces, one corresponding to each move. Now we'll consider the tree representation, using dynamic battle of the sexes as our example. Atop the screen is the extensive form we discussed earlier. We read the tree from top to bottom. With the exception of the nodes at the bottom of the tree, each node represents a move. Each node bears the name of the player whose move the node represents, and each of the descending branches from that node represents an action available at that move. The terminal nodes at the bottom of the tree represent outcomes of the game, and each terminal node is labeled with the associated payoffs. The man moves first, so the top node of the tree, in blue here, bears his name. This top node features descending branches, in blue here, with each branch representing an element of the action space at that node. The man selects boxing or ballet at the beginning of the game, so his node features two branches, one labeled boxing and the other labeled ballet. The woman moves second, after the man, so her nodes, blue here, appear at the end of branches corresponding to the man's actions. At the time of her move, she has perfect information about the history of the game. She observes the man's choice via his phone call. We represent her perfect information by the presence of two nodes with her name, one node representing her move following the man's selection of boxing, and the other node representing her move following the man's selection of ballet. At each of the woman's moves, she selects boxing or ballet. All four of her actions are marked in blue here. However, she has two distinct action spaces, each corresponding to the man's action. We use italic font to indicate an action subsequent to the man's selection of boxing, and bold font to indicate an action subsequent to the man's selection of ballet. Why the distinction? The woman does not select her activity in a vacuum. If the man selects boxing and she selects boxing, she is following him and they go on a date. If the man selects ballet and she selects boxing, they end up at separate places. The blue portion of the tree is the woman's action space conditional on the man selecting boxing. The blue portion of the tree here is the woman's action space conditional on the man selecting ballet. After the man's move, followed by the woman's move, the game ends at one of the four terminal nodes, shown in blue. The left payoff of each pair belongs to the first player, the man, and the right payoff belongs to the second player, the woman. This notation will be our norm for two-player dynamic games of complete information. In the making of this video, I have only just realized that I appear to have ignored a stronger convention to put the first player's payoff right below the relevant terminal node, and the second player's payoff right below the first player's payoff. I appear to have ignored this convention for at least 11, and possibly as many as 15 years. I also can't imagine presenting a game using the notation on this slide and having other economists question my sanity, so I'm going to stick with the notation here. Now, let's play the game. The man goes first. He decides between boxing and ballet. Suppose he selects boxing. The woman observes his action, and now it is her turn. She decides whether to follow him to the boxing match or to go to the ballet by herself. Suppose she follows him to the boxing match. The game ends. The man and woman are together at the boxing match. His payoff is 2, and her payoff is 1. Thanks so much for watching this video in which we defined dynamic games of complete information, the extensive form, and the game tree. In the next video, we'll examine the critically important difference between actions and strategies.